Hello. Hello, and welcome to United Astronomy Clubs of New Jersey. Tonight is the last presentation this season that we will be in person up here at Jenny Jump State Park in Hope, New Jersey. I want to thank everyone who has come out. And while I see a couple people filing down from various telescopes and whatnot, here's a few reminders. You can always check us out on our website, uacnj.org. That's where you're going to find a list of all our member clubs because, yes, we are actually a club made up of other clubs. You'll also find information on where we are, what programs are coming up, as well as all sorts of fun science things we do up here. In addition to that, you can check us out on our socials. We got Facebook, Instagram, Twitter, Discord, and that again, you can reach out, ask any space questions, whether it just be, hey, you got your first new telescope, or just, hey, you know, what is there any fun plans you are doing for that next eclipse? With that, you can also, we are a nonprofit, so this entire year we've been very much strongly supported by you guys, both coming up here and making donations, but also making donations online, where you can find information again on our website or go to Patreon. We also have that now. So tonight, for the people who are here in the live audience, when we go to leave, we are going to use our headlights because we do not like getting run over. I am sure you agree with that sentiment. No making zombies here. Zombie making is tomorrow, according to my town, because that's when we're doing trick-or-treating. That being said, if you need to use the bathroom, we have the porta potty to my right, your left. We also have a little museum and gift shop area and the doorway outlined in red to my left and your right. I'll be in there after the presentation. So we're going to get started with tonight's intro. Tonight's program is The Universe Can Be a Scary Place, especially in October, getting close to Halloween. Our speaker tonight is Walt Windish. Walt has been interested in astronomy since he saw the Pleiades as a Boy Scout. He bought his first telescope in 1985, just in time to see Halley's Comet. He's a member of the North Jersey Astronomical Group and Rockland Astronomy Club. He's been coming up to Jenny Jump for over 20 years, and he's here to take the scary out of the universe, apparently.
Actually, I'm going to put it in the universe, but
Oh
that's
no.
okay.
Well, it is the correct month for that, at least.
Yeah, it's our last night of the season. It's always right around Halloween, and so we try to keep it a little Halloween themed. So I've named tonight's presentation "The Universe Can Be a Scary Place," and I'm going to talk about uh, some objects that are beautiful, but are so powerful they can be scary. I'm going to talk about some things that could be scary if you think about them coming towards us, and then also just some stuff that are not harmful at all, but they look scary because they're different nebula in different shapes. So we'll take a look at that stuff. And I'm going to go through it a little quick because this is just a gorgeous, gorgeous night. And anxious to have you take a look at some of this stuff. Some of the stuff I'm talking about, you'll be able to go and see, as a matter of fact.
And if we're lucky, I'm not going to be scared by random people coming around the building this time like last time.
That's right. Oh, let's see here. Okay, so the universe is a scary place, and that's actually called the Ghost Nebula, and we're going to take a look at that a little later. One thing I always like to point out before we look at the pictures is just how little of the electromagnetic spectrum we see. Our eyes only see the part of the spectrum called visible light, this little area, and there's so much here and here. Here's the infrared all the way to AM radio, and this way you get to ultraviolet, and you keep going till you get to some really powerful gamma rays and the like. Our telescopes do a lot of work right in this area, and so they see stuff that we can't even see, and they use instruments that can cut through dust where our eyes could not see. And also, our eyes are like a camera at 1/30th of a second shutter speed. So when we look at an object, we can't see the color in a nebula. A camera can see a color in a nebula because it can keep the shutter open for minutes, even hours. and that's how they get color. So when I show you some stuff like the Ring Nebula, if you look at it in a scope, I know some of you might have seen the Ring Nebula already today. It just looks like a hazy little ring, and you'll see what it looks like through Hubble's scope pretty soon. Sounds like there's some monsters tearing up this place here. So here's an example of what different wavelengths can do. This is the Eagle Nebula, and it's taken by the Hubble, and it's about 6,500 light years away. That means we're looking at this object as it looked 6,500 years ago, because the light took 6,500 years to get here. This was taken by Hubble in visible light. But we also trained the Hubble telescope on the exact same frame, but in the near infrared. And look at the difference we see in this picture. It's the exact same frame, but look how much dust we've cut through. Here's a side by side. Left is visible light, and the right, they both give it important information, but they give different information that scientists can use. This is a wide-angle view of the Eagle Nebula. This is the scary part. This is the Eagle Nebula that we were just looking at. You see these pillars? They're about 4 light years tall, the tallest one, which means that light takes 4 years to get from here to here. And these pillars are illuminated by this open star cluster, NGC 6611. And you could see that in a modest backyard telescope. And the radiation from this star cluster, even though it's light years away, is still powerful enough to sculpt these columns. It's almost like erosion when you see erosion in a geologic formation and you see columns left. These pillars have withstood the forces of photoevaporation longer than the rest of the gas around it. But here's the weird thing, and slightly scary. Scientists looked at this cluster and determined that one of those stars probably went supernova about 6,000 years ago, which means if it did, it would have blown these pillars away. But since they're 6,500 light years away from us, it's going to take another 500 years to find out if the scientists are right or not, to see if those pillars really did get blown away 500 years ago. Anyone know what that is? Comet, yeah, right. Very good. And that's Comet Hale-Bopp. That I got to photograph Hale-Bopp right from here, back in the mid-90s. And comets are visitors. Most of the comets come from our solar system, and they have really long orbits. They go around the sun. As they get close to the sun, their tails get long, and this ion tail has the lightest materials. They're like gas. And so they point directly away from the sun because they're affected directly by solar wind. But this is the dust tail that's heavier, and so it doesn't get as affected as these. It gets a little bit affected by the motion of the comet. So when you look at the comet, you can tell two things automatically. You can tell that the sun must be over here because this is going straight away from the sun, and that the comet is moving in this direction because the dust tail is that direction from the ion tail. So you can tell the motion of the comet and the location of the sun just by looking at that. Now, there was another comet that's a little more scarier than this one. It's called Comet Schumacher-Levy, and it was discovered a few years earlier than Hale-Bopp. It was discovered in 1993, and it was first detected on a photograph taken in 1993. And by looking at it, astronomers knew that the comet made a very close approach to Jupiter the year before, in 1992. And during that close approach, the comet got broken apart by tidal force. That means the gravity in one part of the comet was so different than the gravity in the back of the comet that it broke the comet to pieces. And there's a mosaic of what happened. It had broken apart in July 1992, and 21 fragments slammed into Jupiter over a period of several days. I don't know if anybody remembers it, even old enough to remember it. But that happened centered on July of 1994. It was a very exciting time for astronomers. So this is a mosaic of all those fragments coming in after they broke up. And those dark spots are the marks left by the fragments. The fragments hit at the speed of about 36 miles per second, and they caused plumes thousands of kilometers high. And they left hot bubbles of gas in the atmosphere and great dark scars that lasted for months and that astronomers could look at. The largest of the fragments were about 2 kilometers, so that's just over a mile large. But the scars you see here are about the size of Earth. So each one of those bigger dots is about the size of the planet Earth, just to give you an idea of the scale we're looking at. So an incoming comet can do quite a bit of damage. And Jupiter often acts like a cosmic vacuum cleaner for us. It deflects orbits, it absorbs comets. It's amazing. This was the first time humans ever saw objects outside of the Earth collide. And of course, scientists have to give it a fancy name, and they call it extraterrestrial collision of solar system objects. It means two things smashed into each other that were in the solar system. Let's see. This is a radar movie of an asteroid. An asteroid is kind of like a comet. It's really a chunk of rock, but it also has an orbit in the solar system, and sometimes it comes close to the planet Earth. So this is another scary object. This particular asteroid was discovered in 1950, and then it wasn't seen for about 50 years. It's about 2/3 of a mile across and was estimated to have a 1 in 300 chance of hitting the Earth on March 16th, 2880. So we're talking 700 years ago, so don't get too nervous there. The European Space Agency has a Near-Earth Object Coordination Center that maintains a list of over 1,350 near-Earth objects. And there's only a few objects that have a better than 1 in 300 chance of hitting the Earth within the century, and all of them are less than 10 meters in size. So this was a special attention kind of thing. So you could see why it stuck out, even though it was hundreds of years. The impact was hundreds of years away. But here's the good news. As our instruments get better, our calculations get better. And in 2015, the chance was reduced to 1 in 8,000. And just recently, the year 2880 impact was reduced to 1 in 50,000. So as we got to measure better, we got to see the orbits. You make just a slight error in orbital calculation, and it can miss us by miles. So when you hear someone say, trust the science, understand that that's a very anti-science idea, because one of the tenets of true science is always test your conclusions with new data. Now, of course, that doesn't mean that you should go on YouTube and listen to some wacko who knows nothing what they're talking about and say, I've done my research. That's not science at all. But science is always retesting their hypotheses. And that's an important thing to keep in mind, because they're revising their models all the time. And I certainly can't fault the European Space Agency for inaccuracy in projecting out 800 years, because I can't even predict what I'm going to have for dinner tomorrow. So I can understand that. And by the way, not to be outdone, JPL has its own Center for Near-Earth Objects, and NASA has a Sentry system, and they're all watching space junk, they're watching the asteroids, they're always revising their data and looking for new data. So here's the now 1 in 8,000 chance 1950 DA asteroid, along with a couple other. The big asteroid that has the best chance of hitting the Earth, and it's a 1 in 2,700 chance of it hitting on September 24th, 2182. about 160 years from now. So to help you sleep tonight, there's no immediate threat to Earth by any asteroids. But I do like to show you some scary stuff just to open your eyes up. You can check it for yourself online. All my information comes online. JPL, NASA, they've got great websites that you can take a look at this stuff. So it's a fun search. But again, if you're looking at a web page by a group called the Comet Cult or something, I suggest you move to another page. Probably stick to NASA for your information. So even with those slim odds, NASA still knows that an asteroid hit could be a potential danger. And they spend a boatload of money to see if they could change the course of an asteroid known as Dimorphos. You probably saw it in the news. It's just very, very recent. September it happened. This picture from Hubble shows an October 8th, 2022 picture of the asteroids, and it shows a debris field 285 days after the September 26th impacts. And scientists continue to study this data. So as you know, they sent a rocket to the asteroid, and they called it a double asteroid redirection test. It was the first such test of its kind. And the investigation team shows that the spacecraft's kinetic impact with the asteroid successfully changed its orbit. So this marks humanity's first time in purposely changing the orbit of a celestial object, and the first full-scale demonstration of an asteroid defense technology. So our first test was successful. We did change the orbit of that asteroid. Of course, many asteroids, known as meteoroids, regularly enter our atmosphere, right? Sometimes they even impact the Earth. They're known as bolides and fireballs, and you hear reports of them a number of times a year. They look like this when they burn up in our atmosphere. Of course, not all burn up, and if they hit the Earth, we call them meteorites. And astronomy nuts pay good money for those little chunks of iron that fall all the way to Earth. So I'm going to move away from incoming projectiles and look at another scary area on this Halloween show. Let's just stop and consider the life cycle of a star for a minute. A star that's about the size of our sun, or up to about 8 times the size of our star, would take this top path. Average star like our sun, when it runs out of hydrogen, starts burning helium, and sooner or later it expands and becomes a red giant. When our sun becomes a red giant, we'll be inside the sun. That's how big they get. But that's 5 billion years from now, so again, no need to worry just yet. After it becomes a red giant, half of the mass collapses into what's known as a white dwarf, and there's an envelope of gas that's left behind that lasts for about 20, 30,000 years and then dissipates. If it's a more massive star, as we're going to see later, it keeps burning keeps burning elements until it gets to carbon, and then it goes supernova and explodes rather than just kind of blows off its shell. It has a cataclysmic explosion, and what's left is either a neutron star or a black hole. But let's consider this path first, the planetary nebula. And this is the Ring Nebula. Some of you saw the Ring Nebula. I saw you looking into the telescope, and it looked like a really fuzzy little smoke ring, really tiny. This is how the Hubble sees it. This is what's left after a star about the size of our sun blows off its outer shell. About half of its matter goes out to the shell. The other half becomes a white dwarf. There's the white dwarf that's left behind. And it's no longer having nuclear fusion. It is cooling off, and we think it'll take trillions of years to cool off. The universe is only about 13.8 billion years old by what we can see, so we're guessing that it's trillions of years. So that's the the Ring Nebula. That's also the Ring Nebula, but with a combined visual and near infrared. This is the near infrared, and you can almost see these shock waves going through it. This was actually not from when it blew off its shell, but when it was a red giant. So that's what we're seeing here. This is the remnant of the red giant, and then it shrunk back into the white dwarf. Well, the white dwarf was the core that's left behind, and then this visible shell, and this will all dissipate in 20 or 30,000 years. This is already very well on its way to dissipating. This is probably about 50,000 years old. This is probably around 10,000 years old or so, that shell. But there are some strange looking planetary nebula. That was the classic, the Ring Nebula. This is the Cat's Eye Nebula, and it almost looks like a little eye looking back at you. But what's really strange, and scientists never expected this has 11 or even more concentric rings. See all these rings? This is very odd. Instead of just blowing off its shell, it looks like it pulsed out rings every 1,500 years or so. And these rings are really bubbles around it. So this is like looking at an onion, and if you cut the onion, you can see the rings around the onion, but it's really each of those rings encapsulates the entire onion. And that's what we're looking at here. We're looking at a white dwarf with at least 11 bubbles of gas around it. And there's all kinds of theories. Thankfully, there's not too many credible alien theories out there. A lot of them have to do with pulsing the matter out, or magnetic fields causing that, or even an unseen companion star might have helped that pattern. But it's very interesting. Our sun right now can hold about 1,300,000 planet Earths. They can fit inside of it, and a white dwarf has the mass of half a sun packed into the size of the Earth. So when you think about it, half the mass of the sun is packed into 1/1,000,000th of the volume of the sun when it becomes a white dwarf. So that matter is very, very, very dense. This is another planetary nebula. It's from the Spitzer Space Telescope, and it used infrared lighting, infrared light coming in from this well-studied Helix Nebula, and it's nicknamed God's Eye Nebula. It's a planetary nebula in the constellation Aquarius. It's about 600 light years away from us, so it takes light 600 years to reach us. And it's one of the closest of the planetary nebulas to Earth. It was discovered in 1824. And here's another beautiful planetary nebula. This one's known as the Little Ghost Nebula. So being Halloween, I had to stick the little ghost in there for you. It's very round and it's very faint. And it was discovered in the 18th century by William Herschfeld using a telescope to explore the constellation Ophiuchus. Remember when a lot of these were discovered, they were discovered without the use of a space telescope or even a camera, especially a color camera. So when these were named, the person who got to name it was really looking at the telescope and just seeing a white fuzzy patch, kind of like the Ring Nebula you might have seen earlier today. So sometimes you look at something through the Hubble telescope and it's so intricate you wonder how that person came up with the name for the object, but you just forget that that person had a lot less visual information to name the object on than we do right now. One last, this is a great example of a beautiful, beautiful object with a lot of power behind it. It could be scary if you even really think about it sometimes. This is a beautiful nebula. It's found in Scorpius. It's known as the Butterfly Nebula. It's about 4,000 light years away from us. So again, we're looking at something as it looked 4,000 years ago. It's got one of the most complex structures ever observed in a planetary nebula. And although it looks beautiful, there's a lot of tremendous power behind that beauty. The spectrum of its center star shows it to be one of the hottest stars known, with a surface temperature of about 450,000 degrees Fahrenheit. Compare that to our sun, which is just under 10,000 degrees Fahrenheit. And that gives you an idea of just how hot this thing is. The original star was estimated to have been about 5 times the size of our sun, but right now it's only 64% of the mass of our sun. So again, stars that end up with a white dwarf in a planetary nebula go up to about 8 solar masses. So this one's about 5 solar masses, 5 times the mass of our sun. The central star itself can't be seen because it's covered in all that dust you can see right here. It's like a collar of dust and rubble that's kind of choking out that center star. And it's also causing this bipolar effect where you have hot gas shooting out in 2 different ways instead of your typical circle around it. It's a highly studied nebula because it's just so different. And so the scientists, up to just a few years ago, thought that all of that effect was due to the ring around that star. But recently, studying this and other bipolar nebulas, they were surprised to see that these bipolar nebulas were all aligned in the same direction. They all had their axes pointed in the same direction along the galactic plane of the Milky Way. And so random chance had to be ruled out. They believe that the current hypothesis is that it comes from a magnetic field emitted by our galactic bulge, and that magnetic field lines up all of these similar bipolar planetary nebula. The outflows are roiling cauldrons of heat. They heat it to more than 36,000 degrees. So as beautiful as that looks, this is 36,000 degrees Fahrenheit in the wings of this butterfly. And they're racing out at more than 600,000 miles an hour, fast enough to go from the Earth to the moon in 24 minutes. And it's doing that day in and day out. So you can imagine how much it's grown in the time that the light has taken to come here, right? 4,000 light years. For 4,000 years since we've seen this, it's been rushing out at what was it? I forget the number. 600,000 miles per hour. Here's another view of the butterfly. That was taken in by the Hubble, just like the previous one, but again, a wider spectrum. They used ultraviolet to infrared, and it gives the scientists more data to study the wings of that. So we've looked at the remnants of stars from around the size of our sun to about 8 times its mass. There are some stars that are much more massive than the sun. Stars greater than about 8 times the sun's mass don't experience what's called the helium flash. They keep fusing elements together until they hit carbon. Carbon requires more energy than it gives, and that's what causes the supernova. When a large massive star gets to carbon in its core, that's it. It collapses in itself and it explodes in an amazing supernova. So we're now talking about this massive star, helium, not helium flash is here, carbon, all the way to carbon. You get a supernova, and then you either get a neutron star up to about 80 times the mass of the sun, and after 80 times the mass of the sun, you most likely will end up with a black hole. I say most likely because this is still theory, but we have good reason to believe that's true. So a supernova explosion are so bright that they're visible at long distance. If a nearby star were to undergo a supernova explosion, it would be so bright that you could be able to see it during the day for weeks. In modern history, no supernova has exploded that close that we could see it during the daytime. But both Tycho Brahe and Johann Kepler saw naked eye supernova in the night sky. In modern history, nothing's come through at daytime. But in 1987, this supernova went off about 163,000 light years away from us. And this is a ground-based telescope image. And with film, it's hard to really appreciate the brightness of the exploding star. But the exploding star, the supernova, was down here. And when it exploded, it outshone this entire area. It outshone an entire galaxy. It was so bright. So the brightness is equivalent to about 10 billion suns. And the energy released from a supernova is equal to the energy released by our sun in 10 billion years of its lifetime, which is its entire lifetime. Our sun is about 5 billion years old, give or take, and it's got about 5 billion, 5 billion years to go in its life. These explosions leave behind super dense stars known as a neutron star. And a neutron star can have a mass greater than our sun, but be only 12 miles across. So imagine all of the mass in our sun crammed into Manhattan Island. It's unimaginably dense. And so the sun weighs about 333,000 times more than the Earth. So imagine a mass of 166,000 suns packed into a space the size of Manhattan. I'm sorry, the mass of 166,000 Earths. So you take 166,000 of our Earths and you cram them into a space the size of Manhattan, and you've got the density of a neutron star. My favorite neutron star remnant is the Crab Nebula. And the reason why I love it so much is that this supernova, when this star went supernova, Chinese astronomers in 1054 saw it, and they saw it as a daylight object. And so in the 1,000 years, less than 1,000 years, it's evolved into this remnant. And so when I look at it, I love to think about the fact that there were people on this planet who actually saw this thing go supernova and saw that star during the daytime after it exploded. And I get to see the aftermath 1,000 years later. The neutron star is like a lighthouse. It spins around. This particular one spins about 30 times a second, the neutron star. If you can imagine Manhattan Island spinning 30 times a second and giving off radiation. It's called a pulsar because the way it was discovered was when scientists were looking with radio telescopes at the sky. These pulsars that were rotating were like lighthouses, and so they would get these pulses 30 times a second. This doesn't look like a very exciting picture, but it was a real breakdown in astronomy. It's Black Widow pulsar, and it weighs as much as 2 suns, but it's only about as wide as Washington, D.C. And it's getting bigger by feeding off a lightweight brown dwarf companion star. And the 2 stars orbit each other every 94 minutes in a deadly close dance. And this is an actual photo taken in X-ray and optical, and it was made possible only by using the gas cloud as a huge magnifying glass. It's like seeing a flea on the planet Pluto. Just an amazing feat. But the actual photo is not very exciting, so we've got some artist rendition of what's going on. The pulsar is seen in the background through the gas cloud. So there's the brown dwarf, which is much bigger than the little pulsar, which is like the size of Washington, D.C., except the pulsar is much denser, and it is sucking matter off of the brown dwarf every time it goes around it. And it's also shooting radiation, right? Being a pulsar, it's giving off gamma radiation in two different directions, the bipolar pattern. And so this red dwarf is shrinking, and someday will be gone and will be totally consumed by the black widow. So the pulsar's beam strips layers away and spins at this is a 600 times a second. It's known as a millisecond pulsar. So if you can imagine that pulsar spinning around 600 times a second and consuming its companion. In this artist rendition, the star system, the binary star system, is too far away to tell the difference between the two. You can only see the glow of the black widow as it consumes. But this is the shock wave as it moves through space. It's moving at about 620,000 miles per hour. That compares to our sun moving through the Milky Way at about 45,000 miles per hour. Back to our diagram. The last thing we're going to look at as far as remnants of stars is the black hole. And of course, it's a black hole because light cannot leave it, so you can't actually see a black hole. This is an artist's rendition of a black hole, and although we can't see it, we can see their effect. Black holes are so massive that they warp the very fabric of time and space. We can see stars whose light paths travel across a black star, and the spot where light can no longer escape is known as the event horizon. There's also another area around the black hole when it eats up matter. It's called an accretion disk. So before you get to the point where light can't escape it, as it eats up matters, stars next to it or gas, all of that heats up and we can see that glow. And that is how one of the ways we can tell we're looking at a black hole. That's the best we can do right now as far as a direct photo of a black hole. And again, what we're looking at is the accretion disk. This is about 55 million light years away from Earth, and was photographed over 4 nights in 2017. Again, what you're looking at is a silhouette of a black hole, and you're seeing the glowing accretion disk of the matter that it's gobbling up. Sometimes we find a black hole so big it's mind-blowing. Right? This is called S50014, and this is just an artist's rendition. He's trying to show the size of this black hole. Most black holes are small black holes. This one is put in contrast to our solar system. So this thing is humongous, and of course it's denser than we can even imagine. This is another artist's rendition, of course. This particular black hole is known as OVV, or optically violent variable. It's hyperluminous. It belongs to the most energetic subclass of active galactic nuclei. All this luminosity comes from the rapid accretion of matter. So it's not the black hole's light that we're seeing, but it's eating up so much matter that it makes it one of the most brilliant objects, luminous objects in the entire universe. To give you an idea of the energy we're talking about here, if this quasar was 280 light years from Earth, it would give as much energy per square meter as our sun does. Right? So it would give us, if it was 280 light years away from us, it would give the same warmth that our sun would. So that makes it about 300 trillion times as luminous as our sun, over 25,000 times as luminous as the 100 to 400 billion stars in our galaxy. And thankfully, it's 12 billion light years away from us. So no suntans from this baby, I'm happy to say. We're going to switch gears one more time. We're going to talk about the Andromeda Galaxy. The Andromeda Galaxy is right up there. And you might even have someone point the telescope at it. So there's something that looks like a great square of Pegasus, a home plate, and over to the left is Andromeda Galaxy. And on dark nights, it's naked eye. You can just barely see it. So the great square of Pegasus would be here. You look at if that's home plate, you look at third base. There's 2 stars going this way, 2 stars going this way, and you go the same distance of these 2 stars up here, and you'll see an Andromeda Galaxy. It's an easy shot with binoculars if you're ever interested. So why would I put the Andromeda Galaxy as a scary object for tonight's talk? Well, most objects in the universe, when you look at them, they have a redshift. A redshift means that their light is shifted towards the red. It's called the Doppler effect. And it means that they're moving far away from us. But there's about 100 galaxies that have a blue shift. That means they're coming towards us. They're mostly local galaxies. And so their relative motion to us is towards us. So if we could see the full extent of the Andromeda Galaxy in our sky, this is how its size would compare. The Andromeda Galaxy is very dim object to us, even though it's the closest galaxy to us. But if we see it brighter, that's how big it would be compared to our moon. This is an even better illustration at a sunset. You see, here's the moon. That's how big the Andromeda Galaxy would be if you could see it as a much brighter object. Okay, so what? It's a gorgeous example of a spiral galaxy. Beautiful. But it's moving at a speed of 196 miles per second towards us when measured in respect to the sun. Right? That means that the 2 galaxies are going to collide in about 4 to 5 billion years. In other words, this Andromeda Galaxy will collide with our Milky Way in about 4 to 5 billion years. The good news is that our sun will have gotten so hot it would have boiled the oceans off of our planet anyway, just about then, before it turned into a red giant. So don't worry about the collision. And when galaxies collide, there's so much space between the stars. You'd think that it's like a car crash, but they just interweave. It's amazing how there's just so much space out there. I mean, 4 light years to the next star from our sun. Of course, there's certainly more dense areas in the universe, but for us, you'd have to go 4 light years just to hit the next star. And it wasn't until 2012 that we had Hubble observations which convinced scientists that the collision would happen. So here's some photo illustrations that just show what it would look like over those 4 billion years. You see the Andromeda Galaxy here. Here's our Milky Way. It's coming closer. It's coming closer. They're starting to interact. There's all kinds of mumble jumble. You're seeing new stars are being born here, and pretty soon we're one big happy family with the Andromeda Galaxy. So here's the Milky and the 2 closest galaxies and their relative size. You see Andromeda is a much bigger galaxy than the Milky Way. There's also the Triangulum galaxy, which will most likely become a satellite of the merged Milky Way Andromeda Galaxy, and then eventually it will merge into those 2. And so all 3 will merge together. And so astronomers can't guarantee that the Triangulum won't merge with us first. That's uncertain. But there's a chance that the Triangulum would merge with our galaxy first, and then the Andromeda would follow. So if we got a merge, I'm hoping that it's a cool merge. Here's what I call a cool merger. The piercing eyes of this creepy space face are the bright cores of 2 distant galaxies in the middle of a head-on collision. So that's what it looks like for 2 galaxies to merge. They're surrounded by a mishmash of stars from their respective galactic disks. And a ring of young blue stars contours the shape of the Erie face. So those are all new blue stars. As gas is compressed by the gravitational interaction, we have stars flashing into life And we also have dense clumps of stars that have come together to form the nose and the mouth of this guy. The ring structure that outlines the face is only going to last for about a million years, and it'll dissipate. And the merging of the two galaxies is expected to take 1 to 2 billion years. And then this area is going to look very different in a couple billion years. So stay tuned for those pictures. This galaxy is known as ARP-Mador 2026-424 for those interested. It's about 704 million light years away from Earth in the constellation Microscopium. And speaking of snapshots, I'm going to just go through a quick. Oh, good, we're on time. We're going to just go through a couple of quick but scary snapshots, in my mind anyway, that are relatively harmless. That's kind of a cool one. That's called gravity's grin. Einstein predicted that if you have a big enough mass and it warps space-time, it will act as a gravitational lens. And we have seen that theory proven time and time again through the Hubble Space Telescope and other pictures that we've taken. So what we're seeing here is these are two very massive. This is actually a massive group of galaxies, so massive that it's bending space-time enough so that a galaxy behind here comes along the outside and is severely distorted, but comes out as a thin spaghetti-like structure. It's a regular galaxy, but because of the distortion of space-time, it's being magnified so that we can actually see it, but it's also being distorted. And we see these all over the place. It's amazing. We've even seen where gravitational lensing has magnified a supernova behind a galaxy cluster, and then you see 4 different instances of the same supernova at slightly different times in different parts of the sky. It's called an Einstein cross. It's an amazing area to take a look at. But I just put it up here today because it's a goofy Cheshire cat type grin for you. But the science behind it is very cool. You know, the two galaxies that are framed by the arcs just happen to make a really goofy kind of a face. Here's another eerie kind of photo for Halloween. It's called the Ghost Nebula. It's a reflection nebula. It's called a reflection nebula because it's being illuminated by stars that are embedded in it. It's really just dust and molecular hydrogen. This is in the Cepheus constellation. It's located about 1,500 light years from us. This is the same object, but I like this picture a little better. It looks really kind of scary. It looks more like a ghost, doesn't it? It's considered a globular. It's over 2 light years across. The wingspan is about 2 light years. So it takes light 2 years to travel across this. There's several stars embedded whose emissions make that nebula shine in the brownish, ghostly kind of color. And if we zoom out from this ghost nebula, this is the picture we started with initially. This is the Ghost Nebula and Little Goblins. It's a wider crop showing a more extended region of the nebulosity, but it's a great Halloween picture. I love it. This I thought was kind of a ghostly picture when you look at it. It's part of the Carina Nebula. It's known as Mystic Mountains. And it's a similar structure to the Eagle Nebula that we started with. This pillar is about 3 light years tall, which is very similar to the Eagle Nebula. It's also a birthplace to stars. And this picture was taken by the Hubble. Another similarity is this also is illuminated by an open star cluster, just like the Eagle Nebula was illuminated by the star cluster. This is also illuminated, and you can kind of see the direction of the star cluster. You know, it's amazing. It looks like it's a spotlight like we'd have on Earth, And we're talking about light years away. The star cluster is bright enough to illuminate this structure light years away. I mean, it's 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 luminous like we don't see in this part of the universe, and I'm thankful for that. Oh, the Skull Nebula. This is the Rosette Skull Nebula, another emission nebula. It's just space dust, space cloud. Uh, its radius 65 light years, so it's a pretty big floating skull out there. It's photographed by the Hubble, and it can be found in the constellation Monoceros. Here's a cosmic bat for you. And boy, look at the ears and the nose and the mouth. That's a pretty scary looking bat. It's an Ophiuchus, and it's rarely imaged because dark nebulas are really tough for astrophotographers to take pictures of properly. It's a very dense material which blocks light from the background stars. And here's another bat for you. Whoa. Nice ears, face, wings. This is the Bat Nebula, NGC 6995. And this bat haunts the Eastern Veil Nebula. The Veil Nebula is a big extended object. Matter of fact, on the western part of the Veil Nebula is the Witch's Broom, which I didn't put up there because I thought he was a lot neater. It's a supernova remnant. It's an expanding debris cloud from the death explosion of a massive star, as we now know. And while the veil is roughly circular in shape and covers nearly 3 degrees of the sky, which is huge, in the constellation Cygnus, the Swan, the Bat Nebula spans only a half a degree, which is still a good amount of space. And finally, the new James Webb telescope has shown us an amazing resolution here of an intricate detail on this slightly scary Death Star in the constellation Gullibilicus. Has anybody heard of that? Well, a close-up reveals that the Death Star is really nothing more than a slice of chorizo sausage posted by a French physicist as a internet prank. But yeah, that was on the internet, and he was praising the resolution of the James Webb telescope. So since we've crossed over into the ridiculous, let me enter a last meme here. I recently saw this meme on the internet. It compares the Ring Nebula with an eyeball and a dying star to the birth of a cell, and the stringy structure of the universe to a brain cell. And it asks, what if the universe is a giant living organism? Ridiculous. Or is it? That is my talk for tonight. And thank you.
All right. Thank you, Walt. I'm actually going to
So
go
we're
around
at the point where
other
you
way.
can ask me any question, and I will answer those I feel like answering.
All right. So about that. So for the people here, when I ask for your questions, what you're going to do is put your hand up and wave it around because I'm night blind since I've been staring at a screen the entire time. I have no night vision. That being said, we do have an online audience who also has questions, but I saw a couple of you sneaking in during the presentation, and you did not get the safety briefing. So first, the safety briefing. We got the bathroom in the form of a porta potty. To my right, your left. We have a little gift shop museum area. To my left, your right. When we are leaving tonight, we are using our headlights. I enjoy life. I no longer work retail, which also helps that. But also not getting run over by cars does also help that as well. That being said, if you need flashlight or anything to walk around, it is dark, keep that pointed towards the ground because we don't necessarily want flashlights in our eyes. All right. So with that, I'm going to start off things with an online question of what is everyone going to be for Halloween?
My kids told me I don't need a mask, so
Apparently Walt's going as himself.
scary enough.
I am some form of witch. Is anyone else in costume today? Just yell it out. No.
Just our crazy staff.
We do have Karen over there. He's the ferryman for Greek mythology who ferries you over this river Styx. I know someone else was dressed up. I've seen them in the dark wandering around, and it was spooky. I haven't yet figured out what they are. Or maybe that was just my boyfriend. But that being said, any questions from our online or in-person audience here?
When a black hole eats up matter, is the information lost or is just embedded?
It is. Yeah, it would not. I wouldn't call it information. Certainly, the matter is consumed, but it's like take a person. If you could even withstand some of that, you'd be stretched like a piece of spaghetti before you got anywhere near that black hole, and you would not resemble anything. And your information, which would be your DNA, would just be consumed within the black star and would be irretrievable.
Well, I guess that's one way. If we ever need to firmly erase those hard disks in the computer, we need to just shoot them at a black hole, is what I'm hearing.
There you go.
Make it unrecoverable by any known form of technology. All right, so our next online question are the scars on Jupiter actually like physical scars? They thought Jupiter was a gas planet, so wouldn't it just be gases just getting mixed up?
Yeah, it healed. It left. The comets came in so fast that they were burning objects that burnt their way through the gas giant. And yes, after a while, you could never find, without a map of where those comet impacts were, you'd never be able to figure out where those scars are because they were in gas. And you're right, they healed up real good within a matter of months.
All right, next in-person question. He had his hand up first. So.
When two galaxies collide and they're going towards one another, what happens then to the direction that they're both moving? Do they move past one another? Does one galaxy start moving in the other direction to go with the stronger, faster galaxy? How does that work?
That's a great answer, and there's no one answer for that, and the math to figure that out is beyond me. But I do know you could Google a really cool galaxy that they found called the Cartwheel Galaxy, and another galaxy, a small elliptical galaxy, passed through that galaxy and changed its makeup so that it now had these gas spokes, and it just passed through and kept going, and we didn't realize the extent to which it was changed until the new James Webb Telescope photographed it in the near infrared, and all of a sudden, what the Hubble telescope didn't show us was very apparent in the James Webb Telescope, and it's very cool. Cartwheel Galaxy, you should check that out. But yeah, it depends on the motion of that the two galaxies approach each other. It depends on the motion of the galactic group, because everything's moving. The sun's rotating, the sun's moving through the galaxy's moving through the universe. So everything is moving, and so it's a very complicated problem to figure out.
I believe another speaker said there was also a chance that it just might look like one of those synchronized walking videos you can find on YouTube where they're all like, you have two groups and they're walking toward each other and you're like, oh no, they're going to crash, and then they go right through each other. And you're like, how? I am not that organized.
There's a lot of space between stars in every galaxy. It's amazing.
All right, so our next online question. Here's the... So when you were saying the gas off of the bipolar star was traveling at speeds, that means you could reach the moon from the Earth in 24 minutes. If travel between the Earth and moon were possible in that time, wouldn't it kill the person on that trip with the massive forces inflicted upon your body?
I would imagine it would. Yeah, I'm no biologist as...
I don't even know what it would take to get that fast.
I mean, to accelerate that quickly has got to tear you apart. I mean, I don't know how many G's that is, but it's certainly enough to wreck your body.
All right. Another question from our audience here. I remember you actually had a question. Yep, she had one because I had multiple questions.
So if somehow a radio could still send a signal from a black hole, would the people who could humans receive the signal, or would the signal just get sucked back into the black hole?
Could
Well,
radio signals
you
escape?
wouldn't be able. You think of a radio signal as light because radio signals travel at the speed of light. If light can't escape a black hole, neither could a radio signal. But then you prefaced your question by saying if it could, but it can't. If you sent it from the just outside the black hole, outside of the event horizon, you could get that signal back to Earth. It might, black holes are a long ways away, so traveling at the speed of light, it could take millions or even billions of years to get back to Earth. But as long as you weren't in the black hole, you could send a signal towards the Earth.
Right. So, I remember you had a question, or was it you? Okay.
Oh, okay. If a meteorite doesn't burn up in the atmosphere and it actually reaches us, what is the probability of that? Let alone finding one.
What is the probability of what?
Finding
Of finding a meteorite that has landed.
Some people are really good at that. They go to the bigger impact craters. Like there's a huge one in Arizona. There's one in Russia. And sometimes when you see people who sell meteorites, they'll tell you what crater they found it at. Then there's other times when upstate New York, it's probably 20, 30 years ago, a meteorite crashed through someone's car. And it didn't make an impact crater, but they found it because it damaged the car, and then they kept looking and they found it. So there are different ways. If you see something racing through the sky, you might be able to find where it's at. If you found a big impact site, you have a much better chance because on impact, that made a whole bunch of little meteorites for you to collect.
I also believe there are various sites, and I forget whether we actually have this linked on our website, but you can actually find micrometeorites.
Find what?
Micrometeorites, because a lot of the meteorites are actually the size of a grain of sand. And I forget the full process, so you're going to have to fact check me on this, but it has to do with, you take, a nice white sheet and you lay it on the roof or somewhere out of the way where someone's not going to track over it. And, you wait a night and then you go back along that sheet afterwards with a magnet, and you pick up tiny little iron bits, which are micrometeorites. And you could apparently send those off to a lab if you really so desire and get them tested for, proof. But there are ways to go about hunting meteorites, and I believe there is actually a good amount of information online about that.
You find them at Astronomy Mates.
Yep. We actually have a few for sale here from the Campo de Cielo, and I know I butchered the pronunciation of that. So.
Okay.
Right. So our next online question was from someone who said, is there any way we could possibly predict when a supernova might happen on some stars?
I can't. Some scientists can. Right. As I said, they looked at the open cluster by the Eagle Nebula, and they figured that a star went supernova. There was a big media splash when someone found out that scientists were thinking that Betelgeuse would go supernova sometime in the next X number of years. So yeah, they could judge by the star if it's close, but close in astronomy is.
Back up.
I don't know why anybody would want to look at me, but okay.
Right. So one of our actual fellow science streamers actually also said there really isn't a way to accurately do this. They said it probably to the nearest few million years, but currently no way to really predict exactly this is going to go down tomorrow.
Well, that's what I was about to say when Chris scooched me over here. A million years in astronomical time is very short. So if they say it's about to blow, if you've got a 10 billion year lifespan, a million years is about to blow.
Right. Another question from our audience here. All right.
If if information is not retrievable from a black hole, then when the black hole sucks in everything in the universe, how will it be possible for life form to form again?
There are many black holes, so it's not like there's a black hole that's going to suck up the entire universe. But there are a lot of theories in cosmology about what happens with this universe. Does it expand forever? Does it contract back? Are there multiverses? That's way beyond my pay grade. I'm sorry, but
That sounds like something you need to make sure you get the good grades, you go through college, and find that information out for us.
the information that the James Webb Telescope is even producing in the last couple months has really turned cosmology upside down, and there's all new theories just by what they've been observing through the James Webb Telescope.
All right. So I'm just putting out a last call for anyone online to get their last minute questions in. All right.
Yeah, please go observe. This is a beautiful night. We got Jupiter, Saturn still up, the Ring Nebula, Andromeda Galaxy. See what you can see.
Right. So the last couple questions I got were, what is the scariest aspect of space to you?
Wow. You know, when I called this talk scary, it was kind of tongue in cheek. But I guess if I talked about scary as far as my personal well-being, I guess it would be an asteroid hitting the Earth. Right? I mean, that if you're talking about an immediate threat, and that's not really an immediate threat, but it's the closest threat you have. And right now it looks like that's hundreds of years away, even in a good case for it.
Mine's just the fact that things are going to jump out at me. I know it.
Okay. Like living things?
It could just be an inanimate object. I mean, you fell victim to that when Chris snuck up on me last time.
That's right.
Where I nearly ended up in your lap. And the next question was actually similar to our in-person question. In your opinion, if you think of some way to escape a black hole, how would it happen? And I swear the person touching me needs to stop. Chris tried it again. He was not successful. The gravel is crunchy.
I have no idea how you would escape a force like that. You know, all I can think of is that there are ways to accelerate around an object by going around it and using the gravity of the object. So there's probably some mathematical formula to show how you could use the intense gravity of a black hole to skirt around it and shoot out, as long as you don't get too close to it. But who knows? That's some good science fiction stuff.
Yeah. Our fellow science streamer also says a lot of meteorites are found in the desert because they're more obvious, because you don't have to pick through the foliage.
Yeah, or the Coke cans.
Right. So it looks like, they actually got really excited that you're like, oh, so you would take a slingshot approach then.
There you
And
go.
they're
Very
super
good.
excited about that. Well, it looks like we're done with questions for tonight. So I want to thank everyone for coming out and joining us both here and online. Like I said, this is our last public program on site for the season. So through the winter, we will be online only. You can check us out on our YouTube and Twitch, where we will be live streaming.
And I encourage all of our online users to grab a pair of binoculars, go outside, and look at this amazing day, amazing night. It's just, at least in northern New Jersey, it's one of the nicest nights I've seen in a long time.
All right. Do check us out on our website, uacnj.org, and have a good night.
Thank you.